Every day when you turn on the news, you might hear something about earthquakes. But what exactly are those earthquakes? Like, many people believe that the earth is just one solid ball, but that is not true. And today I will tell you how earthquakes occur. And to your surprise, you'll find out that the earthquakes actually happens like billions of times per day. But most of them are just too weak for you to realize. In order to fully understand earthquakes, you need to first understand the theory of plate tectonics. The concept is this: the lithosphere, the upper layer of the earth, is made of several plates on just pieces called plates. And these plates always move around because under the plates are the magma, and magma are liquid that can move around. And plates interact with each other. They can move apart, they can collide each other, and they can even slide past each other. So there are three types of boundaries between each plate. One of them is the divergent boundary. From the name, you may notice that divergence means the plates may be together, then they move apart. And then the other one is convergent boundary, which means if the plates are together like this, then they may slide and hit each other, forming a mountain. Then there is the slip and slide, which means that the plate actually slip past each other without making much contact. So this one cause the less. Whenever plates meet, they cause faults. Faults are just the broken part of the earth. And there are several types of faults, like the normal fault. The normal fault is when two plates are on the divergent boundary and they move apart. And when this happens, they actually form some sort of a hill or a mountain. Because when they move apart, then there will be a little area left over, exposed to the surface of the earth. The fault on top, the plate on top of the other plate is called the hanging plate. And the one on the bottom is called the foot plate. And there is another type of fault called the reverse fault. Just from its name, you should know that the reverse fault means the two plates move against each other, move toward each other. And then there is another type of fault called the thrust fault. That one is actually the same as the normal fault, but the plates are on top of each other instead. So it's a horizontal fault actually. And then there is the last type of fault called the strike-slip fault, which this one happens on the boundary in which the plates simply slide past each other. So there won't be much changes on the land. And these faults often cause the earth to shake, and this is the main source of earthquakes. So whenever there are an area with a lot of faults, they are called the fault zone, because that zone is likely to face. Whenever plates move against each other or interact with each other, there will be waves coming out, and these waves are called seismic waves. There are two types of these waves, called the body waves and the surface waves. The body waves travel inside the earth, and there are two types of these waves, called the primary and the secondary waves. The primary waves are faster than the secondary waves, and they travel through all sorts of materials. And it takes the ground according to its path, parallel to its path. And then the secondary waves travel slightly less than the primary waves because it doesn't travel through liquid and air. So in other words, the one that will reach over the earth is the primary waves. And the secondary waves shake the earth perpendicular to the path it travels. And whenever these two reaches the surface, they become the surface waves. And this one is the one that causes earthquake, the big earthquakes I mean. Because the surface wave is like the water wave, so it moves in circle and it travels very slowly. So whenever there is a surface wave, the impact is very long and strong. So whenever there is a surface wave, then there will be something called the epicenter, which is the point on the surface of the earth in which the wave is very strong. And there is a point called the focus, which is the point inside the earth where the wave originated from. I have already told you about the different type of waves. And remember the primary and secondary waves? I told you that the primary travels a little bit faster than the secondary. And the scientists actually use this to an advantage, because the primary waves travel at a ratio of like 1.7 to the secondary waves. And using this, the scientists can tell the difference in the distance between the secondary waves and the primary waves. And using that, the scientists can actually measure just how far is the focus, how far is the epicenter. And the scientists collect the data using seismograph, which pick up the waves and tell how strongly the waves choke. And also, if the scientists manage to get the seismograph record from 3 different locations, then they can use a process called trilateration to pick out a place with the focus.
December 26, 2004 was a tragic date for everyone. Over 220,000 people had been killed. The cause of this tragic event was a tsunami. A tsunami is caused by an earthquake, which was previously explained. This came on a Richter scale of 9.0, a groundbreaking record since 1964. In this short video, we'll look at what causes tsunamis, the physics that drives them, and the effects of a tsunami strike. We will also examine scientists' worldwide efforts to monitor and predict tsunamis in order to avoid disasters like the one that occurred in the final days of 2004. The word tsunami comes from the Japanese word tsu, which means harbor, and nami, which means waves. A tsunami is a wave of series in the ocean that can be hundreds of miles long and have been known to reach heights of up to 34 feet, or that's 10.5 meters. In order to understand tsunamis, let's first look at waves in general. Most of us are familiar with waves from days at the beach or local water parks that have pools. Waves are made up of crest and throws. A crest is the highest point of a wave, and a throw is the lowest point of a wave. Waves are measured in two ways. The wave height is the distance between the crest and the throw, while the wave length is the horizontal distance between two consecutive wave crests. There are several different things that cause a tsunami. An underwater volcanic eruption could be one. A big meteor strike could be another. A landslide on a coastal shelf underwater. But by far the most common is an earthquake underwater. The Earth's plates are constantly moving over and under one another. Sometimes plates get stuck above and pressure builds. When the pressure builds up enough, the upper plate snaps up, causing a jerk upon the water, which jerks the water above it. Now the water needs to spread out. So when the water nears the land, the shallower the shore gets, the more compression is applied to the wave, which causes it to become even larger. Wave heights then reach up to 90 meters above. Use a seismometer to watch for earthquakes. But since tsunamis happen quite suddenly, there might not be enough time. So that's how tsunamis work. So what is a volcano? A volcano is any place on the Earth's surface where there's a hole in the crust where hot magma flows out onto the surface. The outside of the Earth is called the crust, which lasts a few kilometers in most places. Below that is the mantle, which is made up of molten rock called magma. Normally, we would never see this magma, but since the crust covers that, we normally don't see it. But in some places, the magma breaks through. The first range is called the ring of fire, where most plates on the crust meet. The moving plates cause the magma to arise. The second place is the hot spots, which is all over the world. Once magma is on the surface of the Earth, it is called lava. The first type of lava just oozes out from inside and flows over things. This tends to form low shield volcanoes. The second type of lava explodes into the air. This happens when pressure builds up in the volcano. The blast can rise kilometers into the air. Black smoke and dust rises into the air too. This is called a stratovolcano. The last type, scoria cone volcanoes, are characterized by the sides of the volcanoes, which lead up to a wide crater in the center. So that's how volcanoes work. I'm Pratik, and that's how it works.